cosine theta here is equal to, what do we get? What is the R times S? And once again, so before I actually continue, did everybody figure out the difference between these two operations? This is a very simple question, guys. No? Is this a multiplication? No, it's a dot product. What is this a multiplication? Yes. So what my point is, we use the same symbols to indicate multiplication or product. However, when we are multiplying vectors, we use what we call the dot products. And when we multiply magnitudes, we use just regular multiplication. Okay? Do you see the difference between those two operations, even though they are represented with the same symbols? We get to realize it on your own because you're multiplying vectors, not just R times S. Those are vectors. All right, so so essentially you're doing dot product for the numerator, which will be what? U1 or R1 times S1 plus R2 times S2. Guys, have you guys been doing your homework? Dot product stuff. Okay.
More confusing than
Well, if you go back to your notes on the dot product section, it says the aim was dot product and angle between two curves, two vectors, right? Yeah. So that's how we find the product of two vectors using the dot product. So what do we get? We get 3 times negative 2 plus 2 times 9 over the magnitude of R times magnitude of S will be square root of what? Square root of what? 3 squared plus 2 squared, and the square root of negative 2 squared plus 9 squared. And if you write everything out, what do we get? What do you get for the numerator? 12. The denominator, we're at 13. And if you find times what? Red, 22. All right, and if you figure out what the theta become, okay, 85. Red 85, yes, 13 red 85, and what is the theta in degree? 68.8, okay. Are we cool with this? Yeah, with the same exact. So I want you to just confirming the formula. So let me just point it out again that this is a dot product and this is multiplication. So make sure you know how to vote. Okay, so can you go back to number 3 on the other side? On the class activity number 3, and answer that question. Oh, it's one thing. I have 18. Punch out. 0 is not the final answer.
No.
Yeah, so keep going. Question is finding the end.
With 0, writing number 0.
Okay, so keep going.
So I'm going to do the bottom.
All right, so we good? No, I guess not.
Oh, 90 degrees.
Yeah.
Do you want to try to think about it? I just wrote a parenthesis.
Now, will the denominator be ever 0? Unless what? Unless you're talking about a 0 vector, right? But if you remember, going back to the definition of this theorem, it says what? U and V are non-zero vectors. Meaning there has to be a magnitude of some sort for U and V. So therefore the denominator cannot be 0, which works out perfectly, right?